Welcome to this video on the synesthetic shift, which explores the strategic state of multimodal AI from 2025 to 2026. Artificial intelligence is overcoming its sensory myopia. From the rigid rule-based systems of the 50s through the specialized deep learning of the 2010s, we are now in the multimodal renaissance. Multimodal AI enables machines to process context across multiple senses simultaneously, creating a $42 billion market. We are witnessing the end of the text bottleneck. Multimodal AI uses a unified nexus to route information between various modalities. Systems like Meta's ImageBind showed that 6 different modalities could learn a single shared representation, enabling cross-modal retrieval and generation. The 5-layer cognitive pipeline processes data. It starts with data input and pre-processing, where tokens and spectral analysis occur. Layer 3 is the fusion core, followed by Layer 4 processing, which uses cross-attention mechanisms. Finally, Layer 5 generates the output. Contrastive learning is key to binding the senses. This method uses positive pairs to maximize similarity and negative pairs to penalize mismatches. It allows models to learn that a photo of a dog and the sound of a bark occupy the same conceptual space, enabling learning without massive human labeling. The goal is a unified embedding space. By translating text, audio, and visuals into shared mathematical vectors, the AI abandons file formats. It simply understands meaning, grouping related concepts, regardless of their original modality, as shown by the clusters for dog and car. A challenge is the modality gap, where senses misalign. For example, large speech language models suffer a performance drop of about 25% when processing speech directly compared to reading text. This performance decline is due to embeddings being restricted to distinct geometric subspaces, known as the cone effect. This gap is caused by directional alignment versus magnitude divergence. While models align the direction of concepts, they fail to match the magnitude of vectors. The Euclidean distance shows that magnitudes diverge drastically in deeper layers, preserving modality-specific noise. Surgical interventions on the alignment path can correct this. Researchers use angle projection to match the speech vector direction and length normalization to scale the speech vector norm. By surgically correcting just a few weak tokens, semantic understanding is drastically recovered, eliminating factual hallucinations in spoken interactions. Looking at the multimodal market landscape, closed-source models excel in instant deployment and API reliability. Open-source models, however, offer superior economics at scale and absolute data sovereignty, providing total control and privacy. We see a massive video generation leap from Sora 1 to Sora 2. Sora 2 increases maximum length to 15 to 25 seconds, adds synchronized audio, and achieves full 108 OPHD resolution. It also expands input from text to video to text and image to video, including IP integration for licensed content. Multimodal RAG is evolving enterprise knowledge retrieval. Traditional RAG only uses text and outputs text. Multimodal RAG ingests various data like images, audio logs, and video tutorials, outputting a synthesized repair video with overlaid instructions. This capability expands enterprise intelligence to the 80% of corporate data that is not text-based. AI is emerging as a co-developer in the game dev hybrid loop. The old way was a slow, linear process. The new hybrid loop involves AI generating drafts, a human art director refining, AI generating code variants, and an automated AI playtesting agent finding bugs. This shift moves AI from creative replacement to support and scale. The goal is the omnimodal enterprise architecture. By funneling all data, from customer calls and product photos to financial spreadsheets and factory sensors into a unified vector database, intelligence becomes continuous. This supports hyper-personalized customer MRAG and autonomous AI co-developers. The cost of sensory isolation is significant. The transition to multimodal AI is the most critical architectural shift since the Transformer. The technology is ready, latency is solved, and the modality gap is closing. Organizations that remain isolated in single modalities risk structural obsolescence, as deployment velocity is the only remaining variable.